at this one, my H naught is going to be step 1. This is a mean or proportion?
Mean.
Mean. So mean mu1 equals
mu2.
mu2. Good. H. That's not my claim. My claim is
H1 now, so it's mu1 greater than mu2.
yep. Mu1 is greater than mu2. That's my claim. So I'm going to use what word later on?
Support.
Support.
Support. Step 2. Alpha. Alpha is
0.10.
0.10. Step 3, I'm going to do a test. What kind? I have two
Two-stamp
samples.
Two-stamp t-test.
Yep, t-test, because it's a mean. And I'm going to input in my x1, s1, n1, x2, x bar 2, x bar 2, s2,
And
n2,
then 50.
and then greater than. And then of course no. We'll put no. No. For the pool. Alright, so then you ended up with a t-value of, what's your free t-value?
1.02.
1.0 what?
3.
3. And the p-value of 163 or 153? 163? 153? All right, great. So then, step 4,
This is
my
obviously
p-value is larger than alpha,
yes.
so I'm going to
Fail to reject
Yep.
H naught.
exactly fail to reject or not reject H naught, which means that in step 5,
There's not enough evidence to support the claim.
colleges offer more men's sports than women.
Not none.
All right, and we said there's not enough evidence because we did not reject H naught. And support again, gravity down there. All right, good. Okay, everyone feeling good with this? Perfect. Now we're going to hop into dependent samples. Dependent samples are not difficult at all. They're just like
Weird.
two little odd things you need to know about them. And the toughest thing about the dependent is identifying it as dependent. Because what will happen is people will do an independent test on this dependent sample. If you do, that's automatically 7 points off your exam. So 7 points, that's almost a whole grade lower. So make sure that you understand when it's dependent and when it's independent. When is it dependent? When they're matched up in pairs like that. It can be they're matched up like this, where you got 2 rows, like this one, or it could be we have 2 columns that are matched up. Right, but they'll be matched up this way or this way, and they're matched. Does everyone see that? So in other words, this guy goes with this guy, and only that one. Yes? So what happens is, what we do is the following. We subtract them, and then we call these our little d's are differences. So now we no longer have 2 samples. We only have 1 sample. The sample being the differences between the 2 between the two groups individually. So here it's Kennedy and Kennedy's opponent, Lincoln and Lincoln's opponent. You can't mix and match and say Kennedy and Lincoln's opponent. It's got to be the president and their opponent. And so you find the differences between all these, and then it's just a one sample t-test on this. There is some notation. Right, D is the little differences individually. Mu D is the, in theory, the population of all differences. D bar is the average of your sample. And I kind of like to think of this as X bar sub D, because that's kind of, it is sort of like it. Your calculator will call it X bar because your calculator doesn't know better. If you give it a list, it calculates the mean of that list and calls it X bar, calls it X, no matter what. It doesn't know that you've got really D's or Y's or whatever. It just, it uses X as its main variable. S is the standard deviation of your little D's that you have in your sample. And then N is the number of pairs of data you have. Here's the example we did last class. We found all the differences. And here's how we should kind of get the practice of finding these. Because you're going to need to do this on your homework when you have, like these are not hard numbers, you can just subtract them, everybody on board. But your homework will have meaner, nastier numbers. So what we should do is get in the habit of doing this. Stat edit. I'm going to go up here and clear list 1. Clear, enter. We'll clear it. I'm going to start with list 2. In list 2, I'm going to put my first list of stuff. 189, 173, 183. This is all coming from that top row. 180, 179. So that this top row here is what I'm inputting into list 2. $180, 179. And then in list 3, I'm going to put in the bottom row, or the next row, sorry, the second sample. Whoops. I'll talk about that in a minute. And then double check your data and make sure, like here I messed up, I did 85 instead of 185, because if you mistype something there, everything's going to be messed up and you will have no clue what you did wrong. You won't even know you missed anything, and it'll be all wrong. All right, so now I have my first group in list 1, my second group in list 3. I need their differences. I need to subtract them. So I go to list 1, and I'm going to go up so that my cursor is actually on the L1. Does everyone see that? And I'm going to input L2 minus L3. So second 2 will give me L2 minus second 3 gives me L3. So when I hit enter, bam, it subtracts them and puts them in list 1. The reason why I do it this way is because y'all are going to forget on the test when you're stressed out and nervous about other things to put in, L3 or whatever. If you put what you want into L1, it'll just make life easier. It's one less thing to have to remember. So now I can go to stat, test, t-test, and
use data.
Yep, we'll use data. So I'll get to that in a second. First I want to talk about what we're doing here. So here's my example, which I think we did already, right? Correct?
This one.
So first of all, step 1 is always H naught is mu D equals 0. Where does that come from? It comes from this. Mu 1 equals mu 2. That's the same as the other ones. However, for dependence, we're going to make it into one sample. It should not be, we should not have 2 mu's running around there because we're making it into 1. So if I were to subtract mu 2 from both sides, I'd have mu 1 minus mu 2 equals mu 2 minus mu2. I'm just subtracting mu2 from both sides. On the left side, I have mu1 minus mu2. On the right side, mu2 minus mu2 is just 0. Good? And then what's mu1 minus mu2? That's my mu_d, the differences. So that's where it comes from. It comes from mu1 equals mu2, which is the same thing as mu1 minus mu2 is 0. And this is my mu_d, the differences. So we've taken two samples, we really made them into one sample because we're subtracting out all their differences. So this two sample dependent has just a mu_d because we've subtracted them, we're working on just the differences. And we're saying that those differences is equal to 0. In other words, the first mean is the same as the second mean. For this claim, we claim that the first group is larger than the second group, so it means that mu_d should be bigger than 0. If the first group was smaller than the second group, we'd say that the mu_d would be less than 0. And if we claim that the two groups were the same, then that would be h0, and then h1 would become not equal to. Okay? All right. Then, of course, we wrote down our alpha, and we did our t-test. And remember, this is always going to be kind of our, right, this comes from mu_d equals 0. Right? So whatever's in our claim, that's the number that goes there. So we're saying that the differences are 0. So that's the key. You have to remember that the two samples use mu_d, and that 0 goes in the t-test. Only for this one. Do not put 0 in your regular t-test for one sample. Does everybody understand that? So if we're doing a regular chapter 8 one, and I say that, oh, I claim that the jogger's maximal volume is bigger than 63.7, 63.7 would go in there. Does everyone see the difference? This is a two-sample dependent. With two-sample dependent, we're looking at the differences, and we're saying the differences is 0. The difference is 0. There's no difference between them. So only in the two-sample is that going to be 0. Okay. So then I'm going to do L1. Mu0 is 0. So mu0 is 0 only for the two samples. My data that I want is in list 2, my little d's. Frequency 1, you only want one of each thing in your list. And then my claim was greater than. Great. And I ended up getting a t-value of 0.628 and a p-value of 0.282. Good. So that's what we have. And then also, ooh, please note, give me the x bar and the s also. The reason why I want you to give me the s bar and the x is that it will help me troubleshoot where you went wrong on the exam. So I don't have to spend a lot of time trying to figure out to give you extra partial credit. It will kind of help me troubleshoot that and give you some more extra credit without saying, I don't know, and just moving on. Right? So give me the x bar and the s while you're there. They're there, just write them down.
Do you want us to write that on with step 3?
Yeah, or a lot of times people will usually write it
On the side?
yeah, on the side, or they'll write it next to here. Kind of, next to their, like they'll write it kind of here or here. There's a lot of times where people will write it. Yeah, yeah.
Will it say to include them on the exam?
What was that?
Will it say to include them on the exam?
No. It will just, because I'm not going to require you to do it, but it just will be helpful for you if you do it, because it will, again, help me troubleshoot if you make a mistake. Yeah.
Wait, for the exam, it's going to be like a chart like that? So we can like tell the difference?
It'll be, well, the D's you'll have to find on your own. It'd be a chart more like,
Like
it'd be
you
a chart
said,
more like,
didn't you say like someone that are like kind of similar? With
like that. It'll be a chart like this.
Okay.
So, is that one kind of following? Yes.
What were the two things, X bar and S?
X bar and S, yeah. Okay, where were we? Okay, and then finally, because our p-value, right, it's 28%, exceeds 5%, then we fail to reject the null hypothesis. We do not reject the null hypothesis, so we do not have enough evidence to support the claim that presidents are taller than their opponents. Good. So you folks have one to do. First of all, is this a proportion or a mean?
Proportion.
Well, there's no word mean or average there,
Yeah, proportion.
but how do I know that it's a mean? What's my data? Was that?
Numerical.
Are my data, anytime you have data listed, that's a mean in disguise. Because if a proportion, my data is yeses and nos. Does that make sense for folks?
Fair enough.
So since my data is numbers, these are, it's the mean in disguise, which you'll see a lot on the homework that's due tonight, I think. Or maybe the ones due Thursday, I'm not sure. So it's two means. The claim is that first sentence. I'll let you folks kind of work with that. All right, so so let's go take a look at this. Again, I'm going to remind you what one of my students said, which was, if the p-value is low, h naught must go. In other words, h naught is rejected. If the p-value is high, then h naught will fly. It's fine, right? Okay. So we're going to take a look here. And the claim was that to see if the cholesterol level will change. So she's saying that the mean before is not the same as the mean after. Everybody all right with that? Now, if you had said that you think that she wants to see if it will stay the same, will not change, then that's fine, and your claim can be equals. Either one's okay, as long as you're consistent. Is everybody all right with that part? So here, step 1, h naught is at mu. Okay, so we're looking at the differences. So here it's going to be mu d is not equal to 0. So everybody kind of, this leads to that. Yep. So again, h naught, this one's about mu d's. Mu d is equal to 0 is always going to be my h naught. H1 is that mu d is not equal to 0. You could use either one for your claim. I don't care which one. The book uses this one, so that it would use the word support later on. If you did h naught, then you'd use the word reject. Did anybody pick h naught as their claim? No? Like I said, either one's okay. This is a little bit fuzzy.
Oh, I did.
You did? Do you guys want to do it with h naught being the claim so we can see the difference, or is that one kind of want to do like this?
It only be different for like the step 4 and 5, right? Or
It only be different for step 5 only. Only step 5,
not 4?
not 4. Because step 4 is all about h naught. It has nothing to do with which one is your claim.
Yeah, but don't you put whether you reject it or not, or?
So step 4 is all about h naught. It has nothing to do with your claim. So it doesn't matter which one's your claim. We'll try it like this. I'll show you what I'm talking about. Step 4 is all about h naught. So since h naught is always going to be this, it doesn't matter which one's your claim.
This is young.
Yeah.
Wouldn't it not be support, but would it be?
Oh, sorry, it
reject?
would be reject. You're right. Thank you so much.
Okay.
Thank you. Thank you. All right, step 2. Alpha. Alpha is
0.05.
2.05. Great. Step 3, we're going to do, aha, I'm going to put this into list 1, list 2, this into list 3, and then L1 is equal to L2 minus L3. And then I'm going to do t-test of 0, comma L1, 1, not equal to. Okay? So you all did that, and what did you get for your t-score?
1.61.
1.61? Yes?
Mhm.
And your p-value is
7.
point what?
17.
368.
Oh. 1.168.
168. Okay, great. So now in step 4, my p-value 168 is definitely larger than alpha, so I'm going to not reject
H naught.
H naught. And like someone asked earlier, this is always H naught. I don't care, I'm not going to reject or not reject H1, it's always H naught on trial, always. So I'm either going to reject H naught or fail to reject H naught.
Wait, you can write fail to reject, right?
You can do fail to reject, yeah. Just I like the not because then it grabs the not into the step 5 easier. But either one's fine. Good. And so this, it doesn't matter which one's my claim because H naught's the one on trial.
Wait,
Good,
what's,
yeah.
what's the difference between not reject H naught and fail to reject H naught?
There is a difference.
Oh.
If I do not reject H naught, that's the same thing as failing to reject H naught.
Oh, okay. I
You
think
just
you're
have to
saying-
remember-
If I do not put the milk back in the fridge, it's the same thing as failing to put the milk back in the fridge.
You just have to remember to put not first.
Exactly. Right. The reason why I like to say not reject is because in step 5,
Not enough evidence.
not enough evidence makes it really easy.
Just to pop it in, and to also just remember it. Like for example, if you have test anxiety, you might forget to put be not.
Right. That's the only reason why I like it, is that it tells me.
Say it every time.
So here, okay, so here's the difference on which one you picked as your claim. If you pick H1 as your claim, then you'd say not enough evidence to support the claim that there is a change in cholesterol level. Is everybody with me? Yes?
Yes.
But because I picked H naught, no change, H naught would be no change, yes? Then I would say not enough evidence to reject claim of no change in cholesterol levels. Cholesterol levels with mineral supplements, minerals. So because of this, that means that should be no change and reject. Does everyone see that? If I had picked H1 as my claim, then I'd use the word support here to support the claim of a change. Does that make sense? Yes. So that's the big difference there. All right.